Hello, this is again day 2. We're talking about the product of powers. So a new rule still has to do with exponents, but the focus is now on the powers when the exponent is the same. So as a formula, you can write this as a to the n, b to the n equal to ab to the power n. True for absolutely any a, b, and n. And the way you will see that in the homework, it's applied to the case when n is, for example, 1/2. So a to the 1/2, that's the square root of a, b to the 1/2, the square root of b. So we get square root a times square root b is equal to the square root of a times b. And similar rules for cube roots, fourth roots, any roots. As long as the index of the root, that's the little number that you would write on top of this root symbol, is the same everywhere. You're talking about square root, square root, square root, or cube root, cube root, cube root. So it's like this. Cube root a, cube root b is equal to the cube root of a times b. That would also work. By the way, I'm just telling you that this is so. Why is that true, this product of powers? If n is an integer, that's not too hard to figure out. I mean a positive integer. But if we take that on trust, I claimed it's true for absolutely any a, b, and n. So what if n is a negative integer? Definitely harder. And what if n is a fraction? Like 1/2 in that example. Let's give that one about 3 question marks, because that's definitely pretty hard. And this is the sad truth that in Math 140, we teach you a lot of things that would take a lot of time to really develop from the ground up and think about why is that true if anybody doubts it. And there's not enough time in one semester to really just do that. Plus, who really wants to know is always the question, right? So the syllabus says we got to cover this and this and this, and we will just skim over a couple things you should just be aware of, that sometimes you're taking quite a leap and I'm teaching you something that I'm not explaining why, because it would take way too long. It can be done. You can take my word for it. It can be done using all the laws of exponents, the first and second that I told you, and the rule of product of powers with integer n, integer exponent, to get to this more complicated things with the question marks. And it's at least good mental gymnastics. For example, the first and second item here. If you want to try your hand at this with paper and pencil, It's a good exercise. But we will do these examples. And we will do a couple examples here. The square root of 75 u to the 9th power, and all of this is under the square root. The question would just say simplify. And the key is to split off squares, factors that are squares. So I can spot 75 is 3 times 25, or 25 times a 3. U to the 9 is u to the 8 times u. And then we can apply this rule at the top of the screen several times to break up this square root. Right? And we can do the square root of 25, that's just a 5. Square root of u to the 8 is u to the 4. And then the 3 and the u, can't do much about those. We'll combine them, put them back together as 3 times u. And that is what they call the simplified radical form. Your turn. Simplify with the same sort of rules. The square root of 27 x to the 4 z cubed. And I can do that example in lecture tomorrow.